Let's integrate this ln problem. So the first thing I'm going to do is get rid of this nasty squared term here. So this whole integral, once the squared is expanded, is going to become ln x all squared over the square root of x squared is x dx. Now let's do a substitution. So let's let u equal ln x, and we know that du dx is 1 over x. I've got another video on differentiating ln x, and I've got a whole proof. However, I think that's a bit above A-level or school maths. It's probably proofs of that maybe falling into university. But anyway, we now substitute in our parameters. So we've been given 1 and 2. So when x is 1, when x is 1, u equals ln 1, because I've subbed it in here. Ln 1 is 0. X is 2, u equals ln 2, which is just ln 2. So we've got these new parameters that we can now slap in because we've now subbed for u. So you've got an integral of 0 to ln 2, and we can substitute in for u squared, and we've got our du dx, which we can then substitute in here because we need to change the parameter from dx into du's. So once we've subbed everything in, you would have u squared du. We integrate this now, so this would go to u cubed over 3 plus c. We don't really need to care about the constant. And now finally we plug in our parameters. So you're going to have ln 2 all cubed over 3 minus, that's the top parameter, minus the bottom one. So we're going to have ln 0 all cubed to 3. So this here goes to 0. So therefore, our complete answer is ln 2 cubed over 3. So you've integrated it, subbed it, done all the fun stuff, yada, yada, yada. You can integrate.